Hi, in this video we are going to learn about section 9.3 geometric sequences and series. Now in the last example or last section 9.2 we saw that when we subtract the two successive terms we get a common difference, or the differences between them are the same value if we take the current term subtract the previous term, or the next term subtract the current term. Sometimes we don't get the same value and we may have something called the geometric sequence. A geometric sequence is a sequence where the ratio between the successive terms, called the common ratio, is always the same non-zero number. For a geometric sequence an, whose the first term is a1 and whose the non-zero common ratio is r, the nth term is determined by the formula an equal a1, the first term, multiply r to the n minus 1 power. Now this is the formula, the general formula to find any nth term of the geometric sequence, given the fact that we know the first term and the common ratio, which is the ratio between any of the two successive terms. Sometimes we are given just the two terms in a geometric sequence, ak and an. We can also find the nth term an by the formula an equal ak multiply r to n minus k. Let's go over a few examples and hopefully it will make more sense here. Example 1. Find the indicated term in the geometric sequence. Now you are given three different numbers in the sequence and we are asked to find the 10th term. That means what is the term number 10 in this case. The first one minus 1 is a1, or the first term. The second term 2, or a sub 2, and minus 4 is the third term, or a sub 4, 3. Now we are trying to find what is a sub 10, because a sub 10 is the 10th term in this sequence. If you do the testing for the arithmetic sequence, we can take 2 subtract minus 1, the term before that, we get 3, and then we get the next one, minus 4 minus 2, the previous term, we get minus 6. Now we can see that the differences between the terms are not the same, therefore we cannot apply any of the formula we saw in section 9.2, which was the arithmetic sequence. Now if we take the ratio between them, 2 divided by minus 1, that gives me minus 2, or minus 4 divided by the previous term 2, that also gives me minus 2. So the ratio between them are minus 2 and they are all the same, so we call minus 2 here is the common ratio, minus 2, in this formula above here, minus 2 for the common ratio. Now we know that we have the first term a1 to be minus 1. We know that we have the common ratio to be minus 2. We can apply the formula from the above, an equal a1 times r to the n minus 1 power to find an. Now we know that a1 is the first term, which is minus 1. R is a common ratio, in this case it is minus 2. N is n minus 1. So we can simplify this, which is just minus 1 times minus 2 to the n minus 1 power. Now this is an formula. We are looking for the 10th term. That means we are looking for a sub 10. So n now becomes 10. Anywhere we see n, we plug in 10. So minus 1 times minus 2, 10 minus 1. And 10 minus 1 is what? Is 9. So minus 2 to the 9 power, and then have multiplied with minus 1, that gives me 512. So the 10th term for this sequence here is 512. Okay, let's try another example. In this example, we was given the fifth term, the common ratio. We are now asked to find the nth term, or you are asked to find what is an. What is an in this case? Now we are given a phi, or the fifth term. Remember, an formula is given by the first term multiplied by r to the n minus 1 power. We are given the phi to be n, a phi, so phi now is n, so I can plug in phi for n, and I got r, n now is phi minus 1, which is a1 times r to the phi minus 1, which is 4. I know that a phi is minus 7 over, so let me rewrite one more step here. A phi is minus 7 over 4. A1, we don't know the value. We know r to be minus 1/4 to the 4 power. Now, from now we can solve a1. So dividing both sides by minus 1/4 to the 4 power. Minus 1/4 to the 4 power. So I take away that. I can solve for a1 to be minus 7 over 4 divided by minus 1/4 to the 4 power. And that's give me minus 7 over 4 is minus 7 over 4. Minus 1/4 to the 4 power, that's give me 1 over 256. And dividing by another fraction is multiplying by the reciprocal of that. So I got minus 448 for a1. Once I get minus 448 for a1, I can rewrite the general form an equal a1, which is minus 448 multiplied by r. We know r is minus 1/4 to the n minus 1 from the formula. So this is the general formula that we are solving in this case. The next example, we are also asked to find what is the an formula, given the fact that we are given the only two terms in this case, only two terms in the sequence. Well, I know that I can also find an by using an a1 times r to the n minus 1 formula. Now I don't have an. I'm trying to look for an. In this problem, I don't have a1. I also don't have the r. So how do I find that? Now we can apply this one. The first given data here, a3 equal 18. a3 means 3 now is n. So I have a3, 3 now is n. So a1, rewrite that. r also rewrite that. n is now 3. 3 minus 1. And that gives me a3 is equal to 18. So this whole expression here is now equal to 18. And we can solve for a1. So a3 is 18. So I have 18 equal a1 r to the 3 minus 1 is 2, right? 2. So 18 equal a1 r squared. Now we can also use another data here, a6. So 6 now become n. So also have a1 r to the n, which is now is 6. 6 minus 1. So I get a6, which is 13,2122. Now I have a1 r to the 5th power equal 13122. So I have this thing, I have this thing. I can go ahead and take this one, divide by this one. So let me rewrite this one here. A1 r to the 5th power equal 13122, and then divide by this expression here, a1 r to the square equal 18. The reason I want to divide this one because I can take away the a1. R5 divided by r square give me 5 minus 2 give me 3 equal to 13122 divided by 18. I should get 729. And then to solve for this one, I take the cube root of r. I take the cube root of that to both sides. I should end up with 729. The cube root should give me 9, because 9 times 9 times 9 is 729. So I get r to be 9. Now, in this general formula, we are missing a1 and r. Now I am able to find r. The only thing that I need to find is a1. Remember, I got these two equations here and here. a1 and r equal 18. Now I got r to be 9, so I can use any of the two equations here to solve for a1. Let's just use this one here. 18 equal a1. We don't know that. R now is 9, so 9 squared. 9 squared is 81. a1 equal 18. Divide both sides by 81. Then my a1 is equal to 18 divided by 81. We can simplify this one by dividing top and bottom by 9. That gives me 2. 9 times 2 is 18, and 9 times 9 81. So 2 over 9 is my a1, right? This is my a1. Okay, so I have a1, I have r. I can use the general formula an equal a1 times r to the n minus 1 power, and an equal a1 2 over 9. R is also 9 to the 9 minus 1 power. Now they have the same base, 9 and 9. 9 here is 9 to the 1st power. I can simplify that one more time. Dividing the two exponents, they have the same base. We subtract the exponent, n minus 1 subtract 1. I have n minus 2. So 2 times 9 to the n minus 2. This is an formula. Okay, so that is how you find the an formula in general. Now we can also find the sum of the sequence of the geometric sequence. We call that to be the geometric series when we sum all the terms together. So let's an to be a geometric sequence with the first term again a1 and the common ratio r, where the ratio is none, 0, and also not 1. Then the sum Sn of the first n term of the sequence is given by the summation formula k go from 1 to n. A1 r to the k minus 1 up to n, and the whole formula is written as is equal a1 1 minus r to the n times 1 minus r. So this is the formula for the summation of geometric series. A1 is the first term. 1 minus r is the common ratio to the n power over 1 minus r. R is also the common ratio. Let's try an example here. Find the sum. Find each sum. Now we are given the sum the index go from 1 to 12. I's go from 1 to 12. We add all the sum together. We can see that here, the first term, A1, is the first number here, which is 4. And R, in this case, is 3, the common ratio. Now we can see that we have the same type of formula here, so we can apply this formula to find a sum for this one here. So I know that the formula Sn is equal to A1 times 1 minus R to the n over 1 minus R. I want to find a sum of the first 12 term, so I want to find S12 equal to A1 1 minus R to the n over 1 minus R. Now A1 is given at 4. 1 minus R is now 3. Your n now is 12 over 1 minus R is also 3. And if you simplify this one, you should end up with 1,062,880. So that is one example for finding the sum of the geometric series. In the next example, we were not given the summation formula, but we are given a series. The first thing is we also need to come up with A1 and R in order for us to use this formula Sn. And another point here is we need to make sure that this is the geometric sequence with the R is not 0 and 1. And let's try to see what's the value of R. We know that the first term is the first number. A1 in this case is 2. That is easy because we can take the first term. But how do we find the common ratio? So we go back to the last term. This is the general term, An, right? It is given as what? The first term, A1, multiplied by common ratio to the R k minus 1 power. In this case, n minus 1 power. N and k is the same thing. They just use a different type of letter. So we know n. A1 is the first number here, the coefficient. R is just the ratio here, which is 3 over 5. Comparing to this formula here, R is 3 over 5, 3/5. Once you get that, we can start using this formula Sn here. So Sn equal A1. A1 in this case, 2, multiply 1 minus R, which is 3/5 to the n power, over 1 minus R right here, which is 3/5. We can simplify this one further. So Sn is still equal to 2, 1 minus 3 over 5 to the n power. 1 minus 3/5, that is 2/5. Now dividing by 2/5 is by the same thing as multiplying by the reciprocal of that, which is 5 over 2. So Sn 2 times 5 over 2 multiplied by the top, 1 over 3 over 5 to the n power. And the 2 cancel out, you end up with just Sn equal 5. 1 minus 3/5, this is to the n power, and that is your summation formula for the whole series. Now in this case, we was not given how many terms in this series, in the sequence, so we are just finding the sum, the n sum of the n terms in general, we don't find a specific value of the sums. We just find the summation of the nth term in general because we are given the nth terms here. In this case, we know that we are given a sequence with 12 terms from 1 up to 12, and we sum them. Therefore, we get some specific value here. But in this case, we get a formula of Sn, which is the sum of this sequence, the series, followed by this formula here. Okay, so that is the end of section 9.3. You learned how to find a general formula for An of a geometric series, and also be able to find the sum of the geometric sequence. Thanks for watching.